Then comes fault closed loops, fixing problems automatically. Fault closed loops have been one of the early, lead user of automation. Alarm correlation, doing a root cause analysis, or we call RCA in short, automated remediation. These things, some of the fundamentals for a telco operator, and has been one of the leading areas where automation has been applied. It detects fiber cut, correlate alarms, identify the impacts of the services from a region point of view, from a vendor point of view, from a customer point of view, and then you read out traffic and verify the restoration, and all of this done most of the time today without human intervention. Now, how mature it is from an operator to operator obviously varies, but this has been put in place where people can take advantage of it. Performance closed loops. Performance closed loop monitors the KPIs or key performance indicators that take actions and thresholds are breached. For example, increase capacity, adjust power levels, balancing load, optimize throughput. And this can be in a segment or end-to-end on a logical or physical or logical circuit. It can be any combination of anything. These loops keep the network healthy and efficient without a lot of manual intervention. Configuration closed loops. Configuration closed loops handles drift detection, auto rollback, policy enforcement. If a device drifts from an intended configuration, the loop restores it automatically. This prevents outage caused by misconfiguration and one of the biggest source of network failures. And to expand on that, every network device's configuration changes with new software patches or bug fixes, and it is usually done in a controlled fashion during a maintenance windows which operators set. And sometimes during the maintenance windows, the upgrade or change management doesn't go as planned. This is where the network failure occurs the most. Service assurance closed loops, protecting the customer. Service assurance is the fundamental of any service provider. It deals with fault data, performance data, inventory data, customer impact. They answer the most important question from a service assurance point of view. Is a customer affected? If there is a loop, will open the ticket, trigger a remediation, notify the customers and provide status on that customer, and escalate automatically to the necessary organizations, humans or systems, and get the problem resolved. This is where the OSS becomes customer centric. And you measure this performance using customer experience score and a whole bunch of things. Self-organizing network, we call SON. Self-organizing network is a mature example of closed-loop automation. This is mostly used in the mobile networks because mobile networks came in much later than the landline networks, but it's been applied reasonably on a global level on the mobile side. It provides automatic neighbor relations like ANR, load balancing, coverage optimization, interference reduction between cell sites because signals usually overlap with each other, and the SON networks automatically identifies the key parts and make sure that there's no overlapping in signals and thereby reducing the interference. And these are fundamentals for LTE and 5G networks, and it's going to get more and more mature as we deploy 6G networks. The challenges are there for closed-loop automation. Like any automation, there's always challenges. The key challenge is obviously data quality, false positive, or over automation. Like I said, if you can let computer do everything and without any human intervention, it becomes a little bit challenging for humans to fix the problem because they have no idea what happened. Vendor fragmentation, lack of standardization. Closed loop must be designed carefully with guardrails. Safety mechanism, keeping the automation under control, is very important. Safety mechanism can include guardrails, human override option, backdoor options, policy limits, making changes to the thresholds of the policy in a more real-time basis, approval workflows, rollback mechanisms. All kinds of metrics can be put in place to manage the safety of everything from process to workflow to controlling any automation with human level of governance. Automation must be powerful, but it has to be safe. In all, OSS has to provide these capabilities. Now, bringing AI into OSS, the intelligent layer, AI brings fundamentally 4 capabilities: prediction, which is forecasting failures and congestion; classification, classifying, categorizing alarms and events and suppressing them and grouping them in a certain controlled fashion for humans to consume or digest; optimization, finding the best configuration and providing recommendation, or in some cases taking actions on that recommendation; and then anomaly detection, usually looking at variations. This is mostly used in DDoS attack, where you have a network being attacked by external sources to come and inject viruses into your network. This anomaly detection usually spots these type of patterns. AI transforms OSS from being a reactive to predictive network. Machine learning pipelines and the brain behind automation. Machine learning pipelines include data injection, feature extraction, model training, interference, feedback loops. These pipelines continuously improve automation. Predictive automation and fixing the problem before it happens. Predictive automation uses AI expertise, predicting the failures, congestion, degradation of the network, and take necessary actions before even customers sees it or even affected. This is the holy grail of operations. And this is some of the areas a lot of research has been going on, especially in the service assurance area. Intent-based automation is the next frontier. Intent-driven automation allows operators to define the outcomes. AI translates these intents into policies, workflows, and actions, and provides a roadmap and how a network can be autonomous. Autonomous operation, level 5 automation. Autonomous networks are self-configuring, self-optimizing, and self-healing. Human defines the policies, but AI executes on those policies, which is the most interesting aspects of AI. The future of OSS. AI challenges the reality check. AI introduces biases, data drift, explanation, trust, governance. AI must be transparent, safe, and accountable. AI guardrails, responsible automation. This is the most important one, where human provides a lot of value. Guardrails include human oversight, policy boundaries, safe fallback modes, audit trials, and of course, rollback mechanisms where in case something goes wrong or something happens which humans are not anticipated or did not realize it will happen. AI must enhance the operation, not endanger them. The future is basically a zero-touch autonomous network. This is where OS is going to go to. Zero-touch network where human intervention is minimized or literally none. Fully automated lifecycle management, autonomous network, AI native operations. Digital twins, a virtual replica for simulations and predictions. So people can in real time everything, sub-second loops, instant root cause analysis, instant optimization, which obviously a little bit far-fetched, but when you say near time, we can even use the word near real time, which is to a level where human beings can manage the real-time activity. Experience-centric operations. Customer KPIs becomes primary KPIs. The operator of the future is AI-assisted, customer-driven, and data-driven, automation-first, cloud-fluent, experience-focused. This new role is strategic, not reactive.